Hello everyone and welcome back to this next lecture. So in the previous lecture, I had described who the target students of this course are, who would actually benefit from this course. In this lecture, I'm going to describe the hardware requirements of this course. So to be able to follow along with this course, it is extremely important that you not only watch the videos and also write code, but you actually have a physical microcontroller kit with you that you can program along with watching the videos. Because this course will not only cover theory, but will also have live coding sessions, which means we'll be performing projects and we'll be actually coding the microcontroller and you'll be watching me program the microcontroller. And besides this, we'll be actually performing experiments where you'll be seeing the microcontroller in the video with the waveforms and other visual effects such as glowing LEDs or even flashing LEDs. And these are all examples which you will see in this course. So therefore, it is extremely important that you buy a Curiosity Nano evaluation kit. And in the next few slides, I will describe this. So this particular Curiosity Nano evaluation kit, as I already said, is a low-cost evaluation kit provided by Microchip with the PIC32CM MC microcontroller. Besides the microcontroller kit, I will also describe a few other hardware requirements which are necessary for this project because, as I said, all the experiments in this particular course are actual hardware experiments where you will be watching waveforms and you will be also making changes so that you can verify for yourself that the peripherals work in certain manner. So therefore, we will be using the Nano evaluation kit and you will be also using certain other hardware components. This will be described in this particular lecture. So, the Curiosity Nano evaluation kit has the PIC32CM1216MC00032. This is the microcontroller chip that we'll be using in this course. And this microcontroller chip is provided in the Curiosity Nano evaluation kit, and this is an image of that particular Curiosity Nano evaluation kit. Now this is a very small kit which will fit in the palm of your hand, and it has the microcontroller. So this main microcontroller here by Microchip is the PIC32CM1216MC00032, which is the PIC32CM MC microcontroller. Right? There are several other microcontrollers in the same family, and therefore this is one particular microcontroller which I'll be describing once we get to the actual architecture section. Now it has a micro USB that is here, so you can use this micro USB connector with a cable to connect it to your host computer. Right? Now this it not only has a micro USB connection, but it also has an onboard USB debugger. So this is your debugger. The debugger will translate the connection, because remember the USB is a serial connection and this serial connection needs to be having a translator so that it can communicate with your microcontroller. So with this we can now connect the kit to our host computer. We can write code on the host computer using MPLAB XIDE. We can compile our code and we can download our code onto the microcontroller using this USB connection. Right? So you do not need to buy any other debugger. You may need to buy the USB cable once we see the actual requirement. Right? Now, it has a number of peripheral pins provided as pads. So as you can see here, there are a number of pins which are provided as pads. Now, the one thing that is, I would say, the only drawback is that there is no connector, right? This is the actual kit which is available when you purchase it. It comes in a little flat package and there are no connectors, there are no pins, there is nothing to make a connection, right? But these connections have all been provided. And all these are actual GPIO pins which I'll be describing very soon, right? Now, because of all this, we do need to make some connections and I'll be showing that very soon. However, this particular kit has two things which are useful right away. The first is an LED. There is a yellow LED which can be used to either glow or flash, and there is a push button. So you see here, this is a push button which you can actually press, and it is connected to the microcontroller so that you can actually use it as some kind of a serial communication or even an interrupt communication. Again, we won't be going into that much detail because, as I said, in this course we'll be focusing on power electronics applications only. So now the cost of this kit is around $16, and I'm now going to step away from this presentation and go over to my browser where I'll be showing you the actual kit on the Microchip website. So I'm now on my browser. I'm using Google Chrome, but you can use any browser you want. And here I'm just going to click on Microchip. So Microchip has a website which is right here, and you can go through them. They have many products, and especially a lot of products which are specifically for power electronics. And the best part is many of these are low cost microcontrollers which are extremely now becoming popular. So go ahead and browse their products. But what I am going to do here is I'm going to look for the Curiosity Nano evaluation board. So I'm just going to type Curiosity Nano, and this is what we get. So the first link, I'm just going to click on it. It takes us to the Curiosity Nano development platform. So as I said, the Curiosity Nano development kit is only a carrier for microcontrollers. You can have a number of different microcontrollers on the Curiosity Nano evaluation kit, and I would say go through this website and check out all that they offer. And as you can see, these are all the different Curiosity Nano evaluation kit. In this course, we'll be using the PIC32CM MC family, and this particular Curiosity Nano evaluation kit contains the PIC32CM MC microcontroller, and I just showed you a picture of it in the previous slide. So let me go to click Learn More, and you can see this is the detail. This is exactly the same image which I just showed you, right? Matter of fact, I took this image from this website. Now you can order this from Microchip itself directly. As you can see, it's used around 15. It will go up slightly with taxes, or another option is we can go to DigiKey. So DigiKey is a very popular website used mainly in North America. Of course, if you're living in different other parts of the world, feel free to use an electronic distributor that is popular in your part of the world, right? Because remember, this is very region specific, and different other regions will have other low cost electronic suppliers which are much more efficient and provide much better prices. So here again, I will type Curiosity Nano, and you can go to Embedded MCU DSP, and here you'll see there are several of them. Now specifically, if you come over here, you can see that we are interested in the 32-bit microcontrollers. I'll just zoom in a little so that things are a little more visible. So you see, we want the 32-bit microcontrollers, and we are not interested in the others. We are not interested in 16-bit or in 8-bit. So let's come over here and apply this filter. So if you come over here, you will see that the PIC32MC00 Curiosity Nano evaluation board is listed here as well. And you will see that they are exactly the same part number, right? So the same part number can be referenced with different manufacturers. So if I open this, you will see that it gives me the price. Of course, this is Canadian dollars because I'm in Canada, but you will see this in whichever price depending on where you are, right? So this is exactly the same microcontroller. Not a very nice image, but it's exactly the same microcontroller, right? So again, which particular platform you wish to use is totally up to you, but I would say that please do buy this microcontroller kit from some electronic distributor who is local to where you live. So with this, I'm going to go back to my presentation. So I'm back in my presentation, and as I said, I hope you also took the time to check on your local region, wherever you are, for local distributors of electronic components, and you found somebody who can supply this same Curiosity Nano evaluation kit. But the most important thing too is make sure that it has this PIC32CM1216MC00032, right? And if you buy the Curiosity Nano Evaluation Kit, which I listed before, then in that case, you will get exactly the same microcontroller chip, which is provided by Microchip. Right? So now let me go on to describe a few other components which are necessary. So as I said, one drawback is that this microcontroller kit doesn't come with any connector. So there is no header, there is no connector, there is nothing to make any connections to it. These connections will have to be made by us. And for that reason, I would suggest that you buy a header. This is what is called as a multi-pin header. It can be 20 pin, you can have any of these. This kind of connector can be soldered to either side of the kit so that we can then connect jumper cables to different pins. So you can buy 2 of these and connect them to solder them to either side. So you can't solder them to these holes because remember the holes are not aligned. You have to solder them to the sides, and with these we can now make connections to our microcontroller chip. So this is something that you can do. Now you can look for any type of connector, but make sure that it has at least 18 pins and the pins are separated by 100 mil or 2.54 millimeters, because this is the separation between the pads on the kit. So you see these pads, this is where you'll be soldering the particular header, and these pads are separated by 100 mil or 2.54 millimeters. So make sure that whatever you buy, it has at least 18 pins and it is separated by 100 mil. But this is not very difficult to find because this is the most standard type of connector that you can find. And the cost for this is approximately $5 to 10. And you can find this on various websites, and I'll show you that very soon. Now, since you will have to solder this to both sides, so you'll need 2 of these which are soldered to either side of the kit, you will also have to buy a soldering iron. And you will also have to buy solder wire, and optionally you can buy flux paste. Right? Flux makes it easier to actually solder components to PCBs. Now, in terms of a soldering iron, it is totally up to you what you want to buy. But for this project, a basic soldering iron of around 40 to 60 watt is good enough. Right? There are very, very advanced soldering irons which have temperature control and which can control from 200 degrees to 500 degrees. All that is up to you. If you want to buy one, by all means go ahead and buy. I bought a very cheap soldering iron from Amazon for this project, and I spent only $10 on that particular soldering iron. The cost of soldering iron, a basic soldering iron, is around $10 to $15. So now again, I'm going to go to my website, browser rather, and show you where these can be purchased. So I'm back on my Google Chrome browser, and again let me type DigiKey and go to DigiKey. But again, as I said, wherever you are, find whichever electronic manufacturer is the most popular in that part of the world. Right? DigiKey is typically the most popular in North America. That's all. Now once you come over here, type for header. So we are going to search for header. And if you search for header, you will find many of these. Look for header specialty pin. Right? Because remember, these have to be open connections that you're making and not closed connections such as these. So if I come over here, you will find that there are many of these. Right? And as you can see, this is one of them, and there are many. You can just look through. See, for example, this is 20 of them, this is 32, and this 25, many of them. Go ahead, look for any of them. Let me just click on one of them. So you can see this is a 20 pin header. And you will see here that the separation is 0.1 mil. So this is 100 mil, sorry, not 0.1 mil, 0.1 inch, which is 100 mil, or it is 2.54 millimeters. And this is good enough for our purposes. So whichever you choose, make sure that the pitch is 100 mil or 0.1 inch or 2.54 millimeters, whichever is okay. So this is something that you will have to solder to both sides of your kit. Now, I would say go ahead, look for this on your own. I'm going to now open Amazon to show you where you can buy a soldering iron. Right? Again, you do not have to go to Amazon. You can go to any website. The only reason why I'm looking at Amazon is because I am in Canada, and typically Amazon is the most popular for these kind of things in North America. Again, now here I'm going to search soldering iron. And as you can see, there are several options. So now all these numbers are in Canadian dollars. So again, it's totally up to you how much you want to spend. For example, if you want to buy an expensive one with temperature control and everything else, you can go up to like several $100s, or you can buy a really cheap one such as these, right? This is like 60 watts, right? And this is what I have. I have one very similar to this, though I didn't buy it on Amazon. I bought it on a local electronics store. It is just $10, and this is all you need for this particular course, right? Now, there are certain packages which come with everything. So for example, if you like check this out, it comes not only with the soldering iron, but it also comes with solder wire, and it also comes with flux paste. So therefore, this comes with everything, right? So you could also use one of these if you're looking for a complete package with solder wire and flux paste, so that you can then do all your soldering for any other electronics projects that you have, right? So this I will leave to you. So with this, I'm going to go back to my presentation. So here I am back in my presentation, and with these two slides, I showed you where you can buy your kit, that is the evaluation kit, either from Microchip or from DigiKey or from any other electronic supplier, and where you can find these header connectors either from DigiKey or any other header supplier, any other electronic supplier, or you can even buy it from a local marketplace such as Amazon or any other supplier which is popular in your region, right? So now that these have been done, the next few lectures will describe some other components which are necessary for this course, because we need to actually perform experiments, and for that we need some electronic components. Now, I would strongly recommend that you buy a cheap oscilloscope, and the reason is that a large amount of the examples in this course will be related to pulse width modulation. And we are dealing with high frequency signals in kilohertz of frequencies, and those you cannot do those experiments with flashing LEDs, right? For example, if it's only a couple of hertz or a few hertz, the frequencies that we are generating, we could actually just flash LEDs. So, but those are not possible with pulse width modulation, right? Because to make this course practical and actually applicable in power electronics, it is essential that I generate some practical pulse width modulation examples. And for that reason, I would say go ahead and buy a cheap oscilloscope. So I have this specific oscilloscope with me. All right. So this is something I bought from Amazon. And my suggestion is, whatever oscilloscope you buy, please buy one with at least 2 channels. And the reason is that we need 2 channels for comparing waveforms. If you have a single channel, you can observe one waveform, but you can't compare it with anything else. So if you have 4 or 6 channels, by all means go ahead. Like for example, if you are already studying at a company, you're studying at a university or at a company, and you have good lab facilities, go ahead and use good oscilloscopes. You don't have to buy this. This is an option for those who are building a home lab, who are doing this personally on their own and on their own time, right? This one costs around $50 USD. I bought it from Amazon, and I'll show you that link very soon. Whichever oscilloscope you choose to buy, please buy one with at least 10 megahertz bandwidth. Alright? The reason is that we will be generating frequencies, PWM frequencies, up to around 10 megahertz. Around 10 kilohertz, sorry. We'll be generating around 10 kilohertz because we are talking about general switching frequencies for power converters, right? And look for something which is around 50 megasamples per second, right? In terms of its own sampling frequency, because otherwise you will end up with very granular waveforms which don't really look good, nor do they actually give you an understanding of how things work, right? So look for at least 2 channels, look for something with at least 10 megahertz bandwidth and at least 50 megasamples per second, right? Now, this one has a signal generator, but you do not need a signal generator, right? In this course, I will not be using a signal generator or a DC power supply or anything else. The signals will be generated using the microcontroller itself, right? For those examples where you need a different kind of waveform, I will be showing you how you can actually create those waveforms using your microcontroller, right? So you do not need a signal generator. So do not, if you have an oscilloscope With a signal generator, by all means use it, but I would say do not bother with signal generation when you are looking for an oscilloscope. You just need 2 channels, 10 megahertz bandwidth and 50 megasamples per second. Now I'll go over to the Amazon website and I'll just show you how to look for some oscilloscopes. So I'm back on my Chrome browser and I'm just going to type Amazon. Alright, finally it decided I was not a robot. So anyway, let me come and look for low cost oscilloscopes. Alright, and here you will get some low cost oscilloscopes. Now you can actually decrease this cost. I'm going to decrease it all the way up to around 100 because this is Canadian dollars, so therefore that's good enough. And let me click on Glow. So you see some of these will show up, and these are all prices listed in Canadian dollars. Check it out. What's important is, as I said, you must look for something which is at least two channels per second. 2 channels, sorry. So something like this won't do, right? Because clearly it has one single channel, right? And let's come all the way down here. Yeah, this one will do because it has 2 channels, and this is actually the one which I have. Again, I'm not endorsing anything. All I'm saying is whatever you choose, look into them and look for something which is at least 2 channels up. Unfortunately, I do not see a way to actually narrow down your search, but you would have to look through and just look for something with 2 channels and the other specifications which I told you, right? There are a few, and at different, like for example, this is probably more than even that, but anyway, as I said, more channels are always welcome, but do not buy one with only a single channel. That won't work. Like something like this with a single channel will not work because you cannot compare signals. And later when we actually work with pulse width modulation and we are looking at phase shift control, then you will not be able to observe the phase difference between waveforms. Now I'm going to go back to my presentation. So I'm back in my presentation, and besides the oscilloscope, we also need a few more components. So for example, I would recommend that you buy maybe 1 or 2 solderless breadboards, and I'll go over and show them as well. This is very good for connecting auxiliary circuits, right? So for example, I will be showing you how you can connect LEDs to your GPIO pins. You can flash the LEDs, you can turn them on, turn them off, and these are quite useful even in power electronic applications because you can use these pins to control, number 1, LEDs for display, like you want to show to the user that there is an overcurrent error, overcurrent fault, or an undervoltage fault, or sometimes even you want to use it for control, like you want to use it to turn off a relay, which in turn controls a contactor, right? So you want to disconnect your converter from the grid. Then you can use these GPIOs for that purpose. And this way, using these breadboards, we will play around with some small circuits. So the cost of these solderless breadboards is around $5, right? Around about. Now, you should buy a small roll of wire, and I would recommend around 22 AWG. This is necessary for small connections, making connections on your breadboard, making connections from your microcontroller kit and other places, things like that. Again, a small roll of wire is probably around $5. Again, you will need a wire stripper or cutter because quite obviously you do need to strip these wires, you need to cut them and things like that. So please, you will need a wire stripper or cutter. Now, I will use a few resistors in this course. The most common, I will use only one resistor, and this is a 2 kilo ohm 0.25 watt or quarter watt 1% resistor, right? You can buy just a few of these. I would say buy around 4 or 5 of these, or if you want, I will show you very soon on Amazon, you can buy a small box for just around US $10. So this small box will have a resistor collection from like 1 ohm all the way up to 1 mega ohm, and maybe each value is around, you have around 10 of each, right? So that's pretty good to start a home lab. Now you will also need 2 electrolytic capacitors, right? This is when the end, when I'm describing how to use the analog to digital converter, we will be converting a digital signal to a kind of an analog signal. We'll be creating a sawtooth waveform. And we'll be feeding that sawtooth waveform to the analog channel, right? So for that, we need two electrolytic capacitors, 10 microfarad and 22 microfarad, right? So you can buy only these if you want. 2 kilo ohm resistor and 10 microfarad and 22 microfarad electrolytic capacitors. And the voltage rating should be around 25 volts because after all we are working with a microcontroller with max 5 volts, right? So anything more than 5 volts will do. If it can even buy like 12 volts or 15 volts, no problem. You can, however, also buy a small box of electrolytic capacitors for around $10, and I'll show you that on Amazon also. This is if you want to set up a small home lab and you want to play around with electronic circuits, such a box can be useful. Again, they have electrolytic capacitors from 0.1 microfarad all the way up to 1000 microfarad. Now, you will need a few jumper cables, and these jumper cables are necessary for making connections from your microcontroller kit to the breadboard. Alright? Because the reason is that these connections are actually meant, you are supposed to actually connect a female connector below this and mount this on another PCB, right? They aren't actually supposed to be used for connecting here, but we are going to do that. But the problem is these pins are really close to each other, and there's a very real possibility that if you try to use a crocodile clip or something else, you might actually cause a short circuit. So it's better to have a jumper cable, and I should be showing that very soon. And again, you need around 5 or 10 of these. I would say around 5 or 6 of these will also do. But you can buy a small bunch, a small box for around $5. So now I'll go over again to Amazon and show you where you can buy these. So I'm back on my Amazon website. I'm going to go up and now I'm going to search for all those things which I said. So the very first thing is solderless breadboards. Yeah. So this is the second one. And as you can see, there are many options. You can buy a pack of 3, you can buy whichever you want, however you want. As you can see, the price is around, these are all Canadian dollars, so it's going to be even less in US dollars, right? So these are solderless breadboards. Now, I will show you a wire stripper. You can buy any different type of wire stripper. Again, many of these are actually will be both stripper and cutter, and I have one of these. I have something similar to this. So these are quite convenient because you can, main thing is just make sure you can strip a 22 AWG wire, right? That's all that you need to make sure, because some of these have different ranges. They only use some are used only for very fine wires, some are used for very large wires. So just make sure that you know what it is. And I will just say wire 22 AWG. So this, you can buy any one of these, like for example, just one of these will do, or you can buy black and white. You can buy a whole box. You can see there are different prices, again, Canadian dollars. So just check it out, right? Whichever you want. The cheapest is, for this, you just need a few connections to be made. So you don't need a great amount. If there is an electronic store close to you, you can just go buy a small bundle as well. That will be just as fine, right? Now I'm going to go to resistors. So again, as I said, you can buy a small box, right? The main thing is try to buy 1% resistors. Don't buy 5% resistors, right? Because 1% resistors means the error, the tolerable error is just 1%, and that's usually better, especially when you start using small values, resistors of low value. 5% can actually be a fairly large error, right? So choose 1% resistors. You can choose any of these. Like for example, this is an entire assorted kit from 1 ohm all the way up to 3 mega ohm, right? But look at the prices. These are all Canadian dollars. This in US dollars is around 10, right? We need only one, which is around 2 kilo ohm. Even if you use 2.2, that's also okay. If you have, again, if there's an electronic store close to you, just walk over and buy just a few resistors. That will also do. So now that resistors is done, I'll talk about capacitors. And again, here you can see this, you can buy a box, right? So there are different prices. It's an assorted box from small all the way to big. I bought one of these because I'll be doing several such experiments in the future. Again, you need only 2. If you really want to cut your cost, You can buy only a 22 microfarad capacitor and a 10 microfarad capacitor. But if you want to set up a home lab, you can buy any one of these. Right? So with this, I think we've covered pretty much everything. I will go back to my presentation. Actually, I forgot one thing, which is a jumper cable. So let me show you that before I go back. So jumper cables. No, these aren't what I want. Just look for jumper cables for electronics, because quite often you end up with car jumper cables. You don't want those. So for example, if you check these out, these should be good. Make sure that you have male to female. That is, on one end you have a male. This is necessary for connection to your solderless breadboard, and the other side you have a female, which you can connect on your microcontroller pins, right? So this one is an assorted box. So it has like female to female, which you can use for connecting between microcontroller pins. You have male to male. I guess this is if you want to connect between breadboards, and you have a male to female, right? So something like this would be just as fine, right? So this is for 10 Canadian dollars, right? So I think with this, we've covered most of the small components we need. And now I can go back to my presentation. So back in my presentation, this is the list of components that you should buy for this course. Again, they all, unfortunately, when you're doing hardware, you do need to buy some components. So the purpose of this particular lecture was to describe the hardware requirements of this particular course. So as you can see, if you take a sum total of all the components which were listed, you will find that the total cost is around $150. Now it's totally up to you whether you want to buy exactly the components which are necessary, or you want to buy small boxes of assorted components which will give you flexibility in all your electronics projects. But typically, the total cost is somewhere around $150, and that is how much I spent on setting up my own home lab. So therefore, setting up a small home lab will benefit you not only for this course, but also for additional courses. Because in my case, not only will I be teaching this particular course, but I also hope to teach other microcontroller courses based on other manufacturers such as STM and Infineon and maybe Texas Instruments and many more. So therefore, for me, building a home lab was definitely useful. So whether you want to build a home lab or whether you want just the components necessary for this course, that is totally up to you. So I hope this was very clear in terms of what were the requirements of this course and why we need these particular components. If anything was not clear, or you found anything to be not available, or any other issue, feel free to post in the Q&A forum and I'll be happy to help you out. Otherwise, I will see you in the next lecture, where we will talk about some of the software requirements of this course and also the computational requirements. So thank you so much for listening, and goodbye for now.